So test Thursday, worksheet 1 through 3 are due, not worksheet 4. But a little side note, all right, gentlemen, Schoology, Google Student Drive, and then the Unit 12 videos, all the lesson videos are there. But then toward the bottom, review worksheet videos. So they're not due, but there are videos of me working out every problem on there. So I don't know if you want to watch all of them, watch one of them, watch part of them, try them and then watch, just watch. I don't know how you use the resource, but it's there if you want to watch some of those videos. Timing should be okay because multiple choice questions with calculator, you get 3 minutes each, and one free response question should be 15 minutes. So this should be a total of 60 minutes. I'll give you the whole time because, like last time, technology and issues and whatever, but we should be fine on time that day. All the questions are delivered on the computer. You answer the multiple choice on the computer, like last time. The free response question, you will work on your own. And that's how the AP test will be. Like, they will deliver you the free response question on the computer, but you don't have to type in or find all the symbols when you need to write in integrals. Like, your free response answer will be handwritten. AP test day and test day on Thursday. So trying to mirror the test conditions for May 12th as we lead up to May 12th. Grade-wise, the multiple choice questions will be 2 points each. That free response question will be a total of 15 points because that's how free response questions are. That'll make a total of 45, like raw score points. But I'll scale it like I did the last one, which is if you make a 45%, that's barely making a 3, that's barely passing, so that gets you a 70, which means if you get 20 questions right, well, not 20 questions because they're worth, if you get 20 points out of 45, you'll get a 70. And I'll figure out the scale from there. So again, it'll be sort of the AP test scale, where barely passing the AP test gets you to barely passing the test in here. And we'll scale it up and we'll go into the hundreds again, because if you get 100 on an AP test, that's pretty amazing. There's usually like one person per year in the whole United States who gets a perfect score. So go do it. Be that one person. Okay. I want to look at a few problems that I picked, and then I'll be happy to answer any questions that you pick. And what led to this, well, I had picked these already, but in second period, Jace was like, wait, we don't have to do the review, but are there questions from the test like the review? And I'm like, I'm glad you asked, because I've picked some from the review to go over. So probably important to understand the two that I picked. Okay, so worksheet 4, again, not due, but some very helpful problems on there. Let's look at number 2 first. Several reasons we picked this problem. The graphs of the function g and the line y equals x are shown on the figure to the right. The graph intersects at 0, 0, 1, 1, and 2, 2. Which of the following expressions does not give the area enclosed by the graph? So there's the area enclosed by the graph. Forget about these choices for now, although I'm going to ask a question where the choices might help. Like, why is this problem kind of tricky? Why is this problem on an AP test? What's the trick about finding that area? It's like two different areas. The top and the bottom switch. So thinking about that, which one of those answers do you think would be the easiest, best, most conceptual way to find the area? Like 3 of those answers are right, but one of those answers is like the best right answer. I would say C is definitely the right answer, because we'll go from 0 to 1, where we're doing g of x minus x, and then 1 to 2, they switch, which is the above and which is the below. So C is definitely right. C is probably the way most people would work the question. But apparently there's 2 other ways to work the question. D looks closest to C, so let's figure out how D and C are different, or if they're different. So the inside here is backwards. What does that do to my answer if I switched who's top and who's bottom? It would make that one negative. And then same thing here, g of x minus x, that's backwards. So that would make that one negative. But they're all in the, so squaring would fix it, but we're not squaring it. But what does fix it? The absolute value on the outside makes, well, we'd add these and get something more negative and then change the sign, so this one will work. So those are both okay. Which means A and B, one of them's good and one of them's not good, and the only difference is whether we put the absolute value on the inside or whether we put it on the outside. Whether we do the absolute value before we think about adding from 0 to 2, or whether we just add 0 to 2 and then just turn our answer positive. So do you know which one of those would give us the right answer? One of you does. If you make it positive each step of the way, then you don't have to worry about top minus bottom. So like that would work. If you wait to the end, then you're going to get some positives and some negatives, but if you don't switch the sign till the very end, you've sort of lost track of the positives and negatives, and who knows what you're going to get. So this is that one will not work. Well, that's kind of a tricky question. There's 3 right answers and 1 wrong answer. So a couple things about that one. There are definitely some on the test where you have to split them up. I think the free response question is like that. It's not this weird with absolute value stuff, but you definitely have to split up things if top and bottom changes, or if the functions change. There is also, I think, a question that has to do with absolute value on the test. So make sure you're careful about where the absolute value is. Right, the other one that I wanted to work is number 14. Number 14. Let R be the region in the first quadrant, bounded by the x-axis, the graph of y equals natural log of x, and y equals 5 minus x. Now give me a graph, that's kind of nice. I need to figure out which one's which, but one of them's a line and one of them's not a line, so that's not hard figuring out who's who. As shown in the figure on the right. And R is that region. So R is, I'm shading very lightly because I'm guessing I'm going to draw lots of things on this picture. All right, part A. Find the area of R. Do you want to do this as a dy problem or a dx problem? Okay, I'm okay with dx. What do we need to be careful about if we do this as a dx problem? By the way, we're going to do both ways, but if you want to do it as a dx problem, what am I going to have to be careful about? Okay, top and bottom, that's fair. Dx. What will my limits be if I'm doing dx? One to what? Yeah, it's, I mean, I want to go all the way from 1 to 5, but something's going on right here. The intersect, we'll call that A. And what happens at A? Why are we worried about that? Okay, well, who's the top function? Well, that's the question, right? Like from 1 to A, it's one thing, but from A to 5, it's another thing. So I don't mind doing this problem dx, but I got to split this into two pieces. So I'll need to go 1 to A, and then A to 5. And from 1 to A, the top is natural log of x. And from A to 5, the top is 5 minus x. I'm still not quite ready yet, because how do I figure out what A is? How do I figure out where they intersect? Especially if I have a calculator. Let's put them both in the calculator and let the calculator tell us where they intersect. I'm also going to go ahead and label these as y1 and y2. That way, if I use y1 and y2 later in the problem, I'll be okay because I've identified what those are. It's nice when they give me a picture because I can make my window match their picture. So I'm going to go -1 to 6 on the y values, just to make, or the x values. And the last thing I did was -100 to 100. I definitely don't need that. I need like -1 to 2. And then hopefully our graphs look similar. So there's natural log, there's 5 minus x. Yeah, those graphs look pretty similar. Second calc intersection. First curve, second curve, and then let's get close to the intersection. 3.693 ... I can see I'm going to need that twice already, and probably more times for part B and C. So I'm going to store that value so I don't have to keep typing in 3.693 whatever. So I'm going to go back to the main screen, second quit, and my calculator knows that that's the last thing we talked about. So if I just hit store, this maybe looks weird because it's not going to store 1536. It's going to store 3.693 whatever. And dang it, I forgot to get it while I was over there. Only because I've worked the problem before, I know I'm going to need that y value in a minute. So I got to go back and get that. 1.306. Now, your calculator won't remember the y value, so either write it down and then store it, or write it down and keep using it as 1.30, but I don't want to do that. I'm going to store that as b. But the calculator only remembers the x value, so I'll have to type it out. X. And then store that as b. Okay, now I'm ready to go with this problem. Oh, you know what? I can make this look really nice because that's y1 and that's y2. So when I go to my calculator, math 9, 1 to a of y1 dx plus math 9, a to 5 of y2 dx.
1.86.
Okay, but the trick on that one was I definitely had to split that into two pieces. It was sort of like a piecewise equation, like to the left of A was one equation and to the right of A was a different equation. So I had to split that up. There are definitely some on the test where you have to split up. That's why I wanted to do this one.
What was B? What was that?
Just the value of it. That was the y value of their intersection.
Why do we need that?
We didn't for this one. I just know that in the future I'm going to need it, so I wrote it down while I was thinking about it. Otherwise, I was going to have to go back and do it. Okay. This problem can also be worked as a dy problem. I can work this as right minus left from top to bottom. So from 0 to b of right minus left dy. I guess the trick is going to be what is the right side attached to? What is the right side attached to of my little line here? 5 minus x is kind of right. Yeah, everything's got to be turned in terms of y. So it is attached to y equals 5 minus x, but I need it to be in terms of x, so x equals 5 minus y. And the left-hand side is attached to y equals natural log of x, but what does that mean x is equal to? Yeah, we've got to do the fishhook thing, x equals e to the y. So 0 to b, 5 minus y minus e to the y dy. I don't need to do this. This should be the same thing, but I'm going to type it in just to make sure, mostly to convince myself. So 0 to b. And remember, your calculator doesn't know the difference between x's and y's, so I can put that in as x's if you like. I'm going to put it in as y, though. And that should be the same answer we got a minute ago. And it is. So a second reason to work this problem is some problems you can work dx or dy. That's pretty rare. But there was an example one where either way. I still think dx is better because it's no big deal to break it into two pieces. I feel like it's a bigger deal to change everything to y and have to do it that way. All right, part B. Region R is the base of a solid. For that solid, each cross-section perpendicular to the x-axis. Perpendicular to the x-axis. Destiny, what does that tell me?
It's going to be a dx problem.
Yes, it's going to be a dx problem, so good. It means we don't have to be changing things to y's. So it's a dx problem. Is a square. That's pretty good news too, because the area of a square is about the easiest area we could come up with. So I'm going to add up my squares from 1 to 5 s squared dx. I'm going to add up all the squares from 1 to 5. Uh-oh, what? We run into that same problem. What do I have to be careful about here? I mean, this isn't wrong, but the next thing I write What's that?
S equals.
What does S equal?
And that's our ADA bill. Please take attendance at this time.
S is top minus bottom. So natural log of x minus 0. But that's not always true. Because what happens over here, it switches. So 1 to 5 isn't wrong, but that's a little misleading because I'm going to have to split this into two pieces and go 1 to a again. Natural log of x squared dx. And then a to 5 of the other one, 5 minus x squared dx. So again, there's two different tops, two different equations to think about, so I have to split this into two pieces. Oh, and again, I don't have to type in natural log of x because that's y1. I don't have to type in 5 minus x because that's y2. What's that? Oh, you're right. Good. I don't have to do anything else. That's my volume. Right, but do not evaluate. So I'm done. I also would have been okay to write in y1 and y2. All right, part C. Horizontal line, y equals k. Getting too many lines on this picture here. The horizontal line, y equals k, divides R into two regions of equal area. So I'm going to write it as the area above k equals the area below k. So the area above k and the area below k. How do you want to do this? dx or dy? There's a definite answer to this one. Do you want to do this one as a dx problem or a dy problem? Definitely a dy problem. So above k, what are my limits going to be for that orange area above k? K to B. And right minus left, we've done that already, so this isn't too bad. 5 minus y minus e to the y. So there's my area above k. What about below k? What are my limits? 0 to k. And my integrand is the same. It's still the same right minus left. 5 minus y minus e to the y dy. And this is another right but do not solve. So I'm done. That one would be a pain to solve because you'd have to integrate by hand and plug in k as a variable and b is that ugly number. Like, ugh. They probably should have made you solve part B, but there's no way they would ask you to solve part C because that would be ugly. Okay, we've done the ones I wanted to do. So we've done a couple of area problems, dx and dy. We did a cross-section problem. That was the squareds. We haven't done a volume by revolution problem. So do you have a preference from any worksheet? 1, 2, 3, 4? I can pick one. We could go with the one the second period picked. Let's do... You know what? Why don't you try number 5 on worksheet 3? It's kind of similar to what we did yesterday, but it's a different equation. So worksheet 3, number 5.